So it says here Jack is buying a total of items that's $134.45, and he has to calculate the tax to pay on everything. So the tax in BC is 5% and GST is 7%. Oh, sorry, the 5% for GST, 7% for the provincial sales tax. So it's a total of 12%. Now it's important to understand the situations where we add the percentages together or if we're layering the percentages. So tax is a situation where we're adding the percentages together. So we're paying 5% tax on the 134.45 and 7% on the 134.45. Now there's situations where we layer percentages. So there's situations where we can calculate the tax of a 5% of that. And then in addition, we can layer 7% tax that includes a calculation on the 5%. Okay, and I'll show you that in a problem. In fact, I think problem percent of percent will deal with that situation. Okay, so this one here is not the case though, and this is how sales tax works. We can just say that the total tax is 12%. Okay, this is important to differentiate when we can do this. So total tax in this case is 12%. Okay, so this is a situation where we combine the taxes by addition. When we layer taxes, and understand the difference between layer taxes, this will not be the case. So what we can do then is, I want to calculate the total directly. So I'm going to say that the total cost is going to be, and I'm going to do it as a percentage. Okay, instead of calculating 12% and adding on, I'm just going to calculate the total cost directly. And I'm going to do this comparison. I want the 112% to be compared to the total before tax. And that's going to be, the total before tax was $134.45. Okay, and the X then represents the amount we pay after all the taxes have been added on, or the 112%. And again, we were able to add the percentages together in this case. So doing our calculation here, then I can just find my multiplier. It's going to be times by 1.12. I'm going to do the same here, times by 1.12. And so I get 134.45 times 1.12. And I'm going to get $150.58. So I'm just a little bit short. Okay, so I need 58 cents from somewhere to be able to pay for this, or I got to get rid of some of the stuff I bought. Okay, so he's not going to, so there's going to be no change. No change. He needs an extra 58 cents. Okay, so this is something that you guys need to think of. If you're buying something, you have to consider taxes now. Okay, so what they show on the label, okay, is not necessarily what you're going to pay at the till. So you have to make sure you account for that when you're buying things. So Samantha wants to buy a jacket. It's advertised for 35% off. When she gets to the store, the sale's over. She pays 25% more than the advertised sale price. Hey, she bought it for $44. What was the original pre-sale price? Ooh. So we can kind of work backwards on this and say, well, she bought it for $44. What does the $44 represent? Okay, so she ended up paying a 25% more than the advertised sale price. Okay, so the advertised sale price, let's sort this out. So this is going to represent 125% of the sale price. Okay, so 125 represents the price paid. 100% would then represent the sale price. Okay, so then the 100% is sale price. Okay, so I'll put it's not equal to. Okay, so this is a sale price. Okay, so what is the original price? The original price is going to be 65, the 100%, and this would be 65%. So we can kind of start working backwards here. So this is a little bit complicated, but we can work backwards and find out the sale price, and then work backwards to find out the original price. Okay, so let's do that. We're going to compare 125% to 100% first. Okay, so this is $44 X. So our multiplier is going to be our decimal percentage. I want to go in the opposite direction, so I'm going to divide by 1.25. Okay, so 44 divided by 1.25 equals $35. That represents $35.20. Okay, so that's my sale price. Okay, so separately then I need to set up a new ratio where $35.20 represents my sale price, which I'm going to say represents 100% now. Okay, and then the original, so I'm going to say it represents the 65%. Okay, the original is going to then be the 100% price. So now again I have a ratio comparison. I'm going to go 65% to 100% is equal to $35.20 compared to X. And my multiplier in this case is going to be 0.65. So I'm going in the opposite direction, so I'm going to divide by 0.65. My decimal multiplier I'm going to use in the opposite direction. So I end up with 35.2 divided by 65%. So my original price is going to be $54.15. Okay, so this is my original price. Okay, so there's my answer. Now, I want you to appreciate there is an alternative way of doing this. And we can actually use algebra because we basically need to undo this calculation. So what does this calculation actually look like? Well, I'm going to let X equal original price. So to get the sale price, it's 35% off, so I should multiply by 65%. Now, it says that the sale is over and she ended up paying 25% more than the advertised price. So this is my new advertised price here, and I paid 25% more than I wanted to. There's my 25% increase. And that ended up giving me a final sale price of $44. That's my final price. So there's my calculation. Well, I really want to undo this times $1.20 or times by 125% and times by 65%. Well, how do I undo times? Well, I can undo times with divide. And notice that there's my divide. There's my divide. And I'm going to solve for x using divide. So x is equal to 44 divided by times 65% and divide by 125%. So there's my divide showing up. Now instead of doing two separate steps like this, I can do this all in one calculation. And when I do that, I get the same calculation, $54.15. Okay, so this is an alternative way of doing it. Okay, these two go together. Okay, so this goes together. We had to do it in two stages, but we can start thinking of undoing calculations by setting up the actual calculation and undoing it by doing opposites. And this is a strategy we can start using to solve some of these problems. And this strategy is more what we call an algebraic strategy, which is a fairly efficient way of solving problems.